Hey, I'm Boring Cactus, and this is Idle Curiosity. Today, we're going to write a Python program to answer the question, what's the longest gap between exits on a US interstate highway? So, I haven't necessarily planned any of this ahead of time. So, for now, we're going to start by finding where we're going to grab our data, because we need to know where exits are before we can analyze that data. I feel like OpenStreetMap probably has that information. You would think, at least. So... Okay, so yeah, it looks like we can download a bounding box. Or just the entire thing. Oh, that's a lot of data. Okay, so what's the license? There are extracts. Okay, so we can do whatever we want as long as we credit OpenStreetMap. So, we want North America. So that's going to tick along for a while. Oh boy, 1 hour. Yeah, yep, that's going to be an hour. So I will come back later. Actually, I changed my mind. While we wait for that to download, we can Python OpenStreetMap. Oh, hey. What's that? I have no idea. Okay. Okay, so that is useful for this one API. This talks directly to the API. This is not a thing that we want. Hmm. I'm not confident that that's the right thing either. Hmm. So what the hell is this thing? Okay, so that's the thing that we were just looking at. Okay, what the hell is adding? Okay, so that's some bullshit we don't actually care about. So... Okay, introductory level language guide. We might not wind up actually doing this with Python at all. Oh dear God, I do not have the slightest idea. Yeah, I don't really want to mess with this, honestly. And I know because I discovered it the hard way that there is a pretty sizable gap. Uh, so okay, so yeah, that's Ratone. It's Springer. Aha, yep, that's Wagon Mound. And then yeah, 366 and 387. Yep, that interval right there. I almost ran out of gas one time, like a week ago, on my way down. So that's the sort of thing we're looking for. It's like that gap. Okay, so yeah, I'm not. Okay, so that's. Oh man, that's some stuff. Overpass. Okay, yeah, I'm gonna have to like learn more about what OpenStreetMap actually has. So, technical terms. What the hell is a node and a way and whatever? Uh, they don't say. Okay, so a node is a place, and a way is a road. Hmm. A route. Ways that form a major numbered highway. Okay, yeah, so route gives you numbered highways. So, okay, route master. The directions and variant routes for the thing. So it's possible. Hmm. Oh boy. Yeah, that's a lot of stuff. Okay, so we're not looking for notes, we're looking for a route master. Oh, okay, so yeah, we want relation. Oh boy, I don't want to have to understand what that means. Okay, let's not actually download that because that sounds like a mess. What's 9 megabytes of data? I've got a powerful computer. Yep, that is a lot of stuff. Okay, so we've got a relation. I-25 New Mexico southbound. It's part of I-25 interstate highway system. A Oh, hell yeah. This, gamers, is what I was hoping for. So, now all we have to do is figure out what the hell any of this even means. Uh, okay. Okay. I can we filter by ID? Aha, query by element ID. Okay, so relation parenthesis whatever. And we want the U.S. interstate highway system. So let's run that. Oh, fix that query. Aha, we need to recurse a couple of times. Oh, that recursion is not actually doing anything. Okay, yeah, that is indeed continuing to not do anything. So we have to figure out how to do recursing along relationships. So recursion clauses. They don't explain that at all. Okay. Okay. So this isn't actually going to give us anything interesting. Okay. Recurse down. Okay, so that's not how that works. Bruh. Bruh. Okay, so that's not... Okay. So, what if we do that? Well, that's a different result, at least. So yeah, if we take I-25... Oh boy, this is... This is gonna be a lot. Let's not do that, actually. And let's restrict ourselves for now to I-25 specifically. Okay, so that actually works out all right. I think. Oh, no, I clicked the wrong button. So, aha. Okay, so that is a highway equals motorway junction. Is that how that works? Nope. Is that how that works? Nope. Okay. Because what would be nice is if we could filter it down. Okay, yeah, there is still going to be some Python involved here. Okay. Okay, so yeah, that's the way itself. And that is, again, the way itself. And that is, again, the way itself. So, yep. So yeah, I'm not entirely certain why boundaries get drawn the way that they do. But like New Mexico southbound has a bunch of components to it. And I don't get why that is. Okay, so yeah, that's not in fact doing what I assumed that it would do. Let's pick one of those. Okay, so yeah, that happens to be. Oh yeah, because relations in OpenStreetMap are ordered. We saw that being said earlier. Okay, so that's just a list. Yeah, I don't 100% get what all that is. So what about the next one? Nope, that's a nothing. After that, almost. Maybe one more. Yay, so that does in fact cover, at least in theory, the exit itself. Nah, that's actually more depth than we can really get into manually. But yeah, so we've got the overpass API. Okay, so we need to pip install overpass. So let me pull up my command prompt and do that. Oop, access is denied. Install it as me, thanks. Okay. So now we have docs. We're going to make ourselves an API handle. We don't care about the endpoint or the timeout or necessarily the debug. We want okay, and then our script was close that again. Okay, so relation 17,880, and then whatever the hell that means. 177,800. And we will have to remember that this is specifically the I-25. Yeah. Okay. So this whole mess, let's look at the data. Okay, so output, let's control F for JSON. Haha. Okay. So actually, let's make good choices and go ahead and figure out how the hell we filter okay, so when we recurse down relations, it is a standalone query. What the hell does the dot underscore mean? Okay. So this actually, let's filter to southbound in New Mexico so that we can test faster. Because we want, yeah, it would be nice to only fetch the things that we actually care about. So yeah, so we can tell it to only output tags. Okay, yeah. So that saves a little bit of work. bunch of nodes that we don't care about, because the only nodes that we care about are the ones that say that they are motorway junctions. So we need a filter. Okay, so what the hell is going on here? Filters by tag. Okay, so that filter has no input set, so it kind of just does a global search on everything. Uh, hmm. So can we node dot that? All nodes that are already in the input set. Highway equals. Oh, we need quotes. Quote highway quote. Quote highway quote equals quote. Not even gonna assume that I will not typo that. Uh, we fucking did it. Uh, oh hey, there's construction. Huh, that's weird. Yeah, that's... huh, huh, that's weird. Oh well, I think that's probably what we were looking for. Yep, I'm pretty sure that is the exact thing we were looking for. So, wait, hang on a minute. Does it quit being... Yeah, it does quit being I-25 there, because then after that it turns into I-10. Yeah, yeah, that's I-10 going into El Paso or something. God only knows. Okay, so if we go back, then we can get to all of I-25. How long does that take to grab every... Okay. Actually, that might not be good, because then we don't get the information about which state everything is in. Because we've kind of flattened all of our structure. Uh, oh, you don't actually need quotes. But we do still kind of want the structure. So when we recursed, was there a way to recurse that also encompassed... Can we recurse but not flatten? I think the issue is probably the union. Okay, so what the hell does that even mean? Okay, so it's just a thing that's parenthesized. So we will keep all of the relations and ooh, bruh. Empty query is not allowed. Relation. Okay, so like, so like I-25, the type is route and the route is road. Oh, network is USI. Is that gonna go anywhere? Yes. Yes, it is. Okay, so it's guaranteed to be route equals road. Is that enough? Okay, that's not actually making me... Oh, okay, 30, that's not miserable. Uh, oh dear. Uh, oh. Not all of the relations that are roads, just the ones that are, like, part of what we've already found. Thanks. So... Okay, and then out... output the body. Fix it? Is that gonna give us... Okay, so we are back to where we started, except worse off. Did we at least manage to keep the relations themselves? Because if we did... Yep, we do still have the relations. So yeah, okay, so we filtered down to the relations and we include... So yeah, we filtered down to the relations and then we recurse okay. So yeah, so we take We take the roads. So yeah, we recurse and we grab the roads, and then node.nodes. So we grab both the relation and the nodes that we care about. Ooh, but we've thrown away the intermediate information. Of the ways. Okay, so what does recursing up do? So it does not recurse up to, so we want the ways that include nodes that we care about, but not the ones that are in general part of the thing. So we have all our nodes for all of our exits, and then that's a lot of nodes. Oh, so this is all of oh hey, yeah, this is all of I-25, so of course it's a lot of nodes. Because there are a lot of exits on I-25. Okay, and so then we have ways, which we hope are all relevant. But honestly, half of them won't be. And then we've got our relations. This is gonna be interesting. All of the relations, all of the ways that are part of the roads, and then only the nodes. Bruh. Okay, so we've got, okay, so we need all of the relations, all of the ways, and then only the nodes that are actually interesting. Oh, we don't have a separate query set for, or input set for the nodes, so bruh. So We have relations. And literally nothing else. So what if we ditch that? And ditch that. We have relations. And that's kind of it. What if we throw out the relations? Do we get nothing? No, we get ways if we throw out the relations. So point that at dot everything. So then we want everything from the relations, everything from the ways, and everything from the nodes, but actually just the exits. Okay, we've got nodes. We've got ways. We've got relations. This is all of the stuff. Let's rename that from .everything to .all, so we don't have to worry as much about it, and throw in the parent relation just so we have it. Okay. So, we'll throw that in a global just to have, so that we can Okay, so let's let's check out how the pretty print function works, because depth, okay. So pprint depth, yes. So depth, okay, yes, that's the number of levels which are printed. So pprint response depth equals 2. Okay. Oh, overpass syntax error. Oh, presumably it is automatically being told to do JSON already. Oof. Depth equals 2 might have been too much. Okay, so it's got features. It's a feature collection with some features. Now, assuming that like math still works, yep, it's okay. So that's just all of the things. So we're going to have to sort them. You can live over there. Okay. So, to reconstitute all of the structure that we no longer have. So, actually, give me back the... So, is there a way to get the output to not include... Okay, so this will include the IDs and tags, but not the coordinates of members. We need the members, but we don't need the... we don't need the coordinates because we don't actually care about the coordinates. But that's life, I guess. So... So, so let's figure out what our options even are for okay. So grab counter and let's figure out. Okay. So X probably have to access these like a dict. Yes. Type for X in response.features. With luck. Okay, so how does the counter class... So we don't need necessarily to pretty print, we can just regular print. Oh, Mel, don't do silly things. Okay, literally everything that we have is a feature. Okay. So that's not necessarily interesting. Okay. Okay, so how many do we even have to deal with? I'm sorry, OpenStreetMap people, that I keep... Oh, 5,840. So, let's print off every 1,000 of them. Every 500 of them. Just to see where we're at. Okay. See, I don't think we still need the counter. Okay, so we've got Okay, so there's actually nothing whatsoever that identifies this thing as a way instead of a node. That seems less than ideal. Oh, don't use GeoJSON because it sucks. Oh, build equals false. Uh, okay, so let's not make any more assumptions. Oh, apparently that's not how that works. Okay, yeah. So this is starting to look more like what we expected from Overpass Turbo, the fancy gizmo here. So yeah, we have an elements array, and it's got a bunch of stuff in it. Oh, right. You can't just do that because this isn't JavaScript. Okay. So we have types. Presumably IDs are globally unique and not just unique within a type, but I'm not sure I want to count on that. So let's make some let's make some dicts. So we're going to have nodes, ways, and get those last 10 in there just on principle. We did not need all of the last 10. Okay. Type relation. Can't make a variable just called ID because that's a built-in function, and actually we totally could, but I'm just not gonna. This element's ID is the ID of the element. So if we are a node, then put us in the nodes dict, and type is way. Relation raise value error and let's change how we set this up from pprint import pprint, and then how do dicts? Okay, dot items is probably a real thing. Print some nodes and print the nodes, print ways, and print. There's almost certainly a better way to do that, but I don't know what it is. Print relations, print list. So if we don't get a value error, and we just get some data, then we're good. And it looks like we are in fact good. So, yep. So yeah, we've got some ways, and they've got nodes, and they've got relations. Our root relation, let's hang on to that. Let me Python. I forget if this is a thing that you can. Okay, so yeah, as of 3.6, which I think, yep, this is 3.7.2. So as of 3.6, we can do some root 7,800. And then, if I'm lucky, you can bracket root relation with luck. You can do f strings with triple quotes. That would be very nice. And usually if a thing would be very nice, Python goes ahead and gives it to you. Yep, that is in fact what we get. So we have the correct set of stuff. Unfortunately, I think we're gonna miss things at the edge of states, but it's probably not likely for a reasonably interesting gap to fall along a state boundary, because usually on one side or the other there'll be something pretty quick. Something pretty quick, I think. So, we have an empty list of gaps. So we start with an empty list of gaps. And then we have a root relation. Okay, and I meant to have that be a thing, but I have decided it's not actually necessary. Which means I get to manually de-indent things because idle, which I'm honestly only using because I thought it would make a funny series name and not because it's actually the best tool for the job. Doesn't actually let you unindent selected text with Shift Tab. Someone should probably fix that. Okay, so yeah, we do have some relations. Okay, yeah. So okay, so we process a way based on an ID. Actually, no. This is going to be a two-step process. First, we build the list of exit names within a relation. And second, we scan that list for gaps. So So we build gaps based on a relation ID. We grab the ID out of it. And then we loop through the members. And then if it's itself a relation, and then we have a parent relation like this one, which is I-25 super, and check to see if children are relations or ways. So if the first member is a relation, we're going to assume that none of these contain some relations and then some ways directly. It seems like that wouldn't necessarily have to be the case in principle, but I'm fairly certain it is in fact the case. So we have if we have children that are relations, so we will build gaps on the child every child. Actually, no. We want to preserve the relation itself, but I think actually we only really need the tags from it. So now we can assume the children are ways. And we can say, okay, grab the ways member ID. Nope, it's not called ID, it's called ref. And then within a way, we have nodes. We have tags which we don't actually care about. These nodes, we'll call it way nodes. So for all of them, if node ID in nodes, grab the node, and we'll make an empty list. If it has a ref, exits.append node tags ref. And that should give us the name of the exit. So if we then print the exits and then return build gaps on the root relation. We aren't done yet, but we'll be making some progress, at least. Okay. So yeah, that looks reasonable. So what would happen? Okay. So we do so so we do need to strip off letters and things that aren't digits. Is it regex time? This is a little bit overkill, but also, who cares? Library reference, regular expressions. sort. We don't need counter, and we aren't likely to. Okay, so I think we probably don't need that anymore. So yeah, we want numbers instead. So we will parse int search it starts, and we have one or more digits. The match group 0 will be the whole thing, and we can probably just assume exits equals sorted list of parse int x for x in exits. Actually, help sorted. Okay, reverse equals true. And then gaps equals a minus b for a comma b. Zip exits starting at 1. We probably don't still need to print the overpass query since we're confident now that it's working. Okay, yeah. So yeah, that looks like numbers to me. Although a minus b, a b. Actually, what if we don't do the parsing yet? This means we're parsing each thing twice, but I'm a little bit okay with that because we want to know not just how big the longest gap is, but where the longest gap is. Okay, so how does sorted work again? Because I help sorted. Okay, key. Okay, yeah, because we don't actually want a lexicographical sort, because we want the numbers that we wind up with to be strictly decreasing. Okay, so what we would like to do now is flatten, but with all of the context. So Okay, so let's pretty print the entire data structure that we have so far. Oop. I changed how I do that, so I don't actually need to pprint.pprint because I just went in from pprint import pprint. So, well, I didn't actually need to do that. We don't want the exits, we want the gaps. Actually, let's break ties by whatever alphabetical trash was included, so that if we sort descending, then we get... Okay, yeah, so then we get 10D, 10B. Okay, yeah. Get largest out of a set of gaps if is this a leaf or not? If I think the opposite of a leaf node is an interior. Okay, so in both cases we have tags first, and in both cases we have a list second. If is instance gaps 1, 0. Okay, yeah, because this is a list and this is a list. It's a list of tuples and it's a list of tuples. I've also heard it tuples, but I think I googled it and neither is valid. And then this is a list of these. This is a list of those. So the first thing should be an int. We're getting there. Hour and a half-ish in, and we're getting there. Oh, that's... Okay, yeah, so the parent is in fact not a leaf. So that much we've done correctly. So tags children equals gaps. The child largest is get children largest equals get largest. List to get largest child for child in children. Because if we contain a list of highways, then we want to recurse through each of them and get the largest gap within each one. And then we can just ignore that for now, because right now the leaf will error out anyway. Okay, so we have a thing that looks like a leaf, and the second half is indeed leaf-shaped. So we want the max name. Okay, so yeah, I think name is about all we need. So I'm not paying attention. It's called gaps, not gap. Okay, so we are actually almost done. Okay, so is that many miles between exits, low exit, and high, throw in a new line there, exit on highway. Miles. Longest gap. Okay. So we've got 21, 366, and 387. Is that the thing I was grumbling about? I want to say yes. Yep, 387 is Wagon Mound, and 366 is the thing after that. So yeah, that is the longest gap on I-25. And so now all we have to do for our answer is to go back and look at the entire interstate highway system and hope that I did all of the recursive stuff correctly, because otherwise I'm gonna be sad. So, Let's get some progress going on. Datetime.now, I'm pretty sure is a thing you can do. Import datetime, no, from the datetime library, import the datetime class. Datetime.now, yes, you can in fact do that. So started request. Okay, so this way we have at least some indication of how long we had to wait. With luck, it won't be forever. But as long as I did the recursive parts all right, which I think that I did. Yeah, because we already handle one level of recursion, because it includes the root. Oh, beans. Oh, timeout 25 seconds. Okay. So, overpass, API, whatever, timeout, aha! You can set it to whatever you want. So we will make the timeout be a lot. Oh, timeout doesn't fit into C interval. Okay, yeah, no, 6 billion is not in fact going to fit. Oh, 2 million? Regardless, that should be plenty. With luck, we don't get a server timeout. I will go ahead and preemptively check how to not have server timeouts, because we have access to that information. And the server is not promising to actually honor requests with a large timeout, so we probably don't want the timeout that we ask the server for to be higher than it actually needs to be. I'm a little curious now. Are we using bandwidth? Hey, oop, none type. Oh. Okay. That's not optimal. Okay, so it did only take like a little over a minute. So 120, 120. Control delete usually deletes one word at a time and doesn't consume all of the punctuation afterward, but in idle apparently it does do that, and that's not really optimal. Okay, so we had a match that failed. So we will throw out all of the exits that don't parse. Let's... So how's everybody doing today? You can't answer that question in real time, but I've got slightly over a minute to kill, and I don't have anything to say. Hopefully this hour and like 45-minute-ish, probably by the end of it, video is going to be interesting. I have no idea how likely that actually is, though. But yeah, if somebody actually watches this, let me know down in the comments if you thought it was interesting and worthwhile. And if you learned anything interesting about Python or OpenStreetMap. I know I learned some things about OpenStreetMap that I was not necessarily expecting to learn. Or if there's like ways I could be doing this differently that would make it more educational. If I could be slowing down more when I write the code, explaining it better. Because I haven't decided like if I haven't even decided if I want this to be like a semi-regular thing. But if you have an interesting question in the comments that you'd like, yeah, if you have an interesting question that you think could be answered with a Python script and some research, then absolutely let me know. I welcome suggestions. This seems like it's been ticking along for... Oop! We have... Oh, yeah, rest area is not a valid exit name. You don't say. So yeah, that one took a shade over a minute. Okay, so build gaps. We grab the ways. Okay, so we didn't get the way. So that sounds like... Did we get cut off in the data? There shouldn't be a default... Oh, there is a default max size. Oh, but that's not actually attached to output. It's just... Yeah, that's not the number of things that are output, so it won't truncate, it'll just give up. So... Skip this one entirely if it's a ref that we didn't even get. And boom. Okay, so yeah, we started at 802, so we're gonna 802.43, so probably like 804 by the time that one gets back to us. It would be a little bit cool if I had an easier way to cache. I totally could have an easier way to cache the responses. I'm just lazy and didn't implement it. And yeah, if this fails another couple of times, then I might actually just go back in and implement that so it caches the results. How much of a nuisance is that going to be? Probably not a bunch, because since it's literally just persisting through JSON anyway. JSON I don't think it'll cause problems if I play with the file while it's running, because it'll just keep using the version that it already opened. 804. Oh boy. I think the server is starting to resent me. Try response equals with open. Okay, yeah, yep, it's time. With open data JSON R as file response equals, how does that work again? JSON dot load from the thing. JSON dot load file except okay. So this one took more than 2 minutes to get back to me, so presumably I'm getting like rate limited by this API endpoint, and if I switched to one of the alternative ones that they list on the wiki, then I would get slightly faster responses. Okay, yeah. So yeah, there are like two. Okay, so the main servers work like round robin. So I can't actually dodge the API limit by switching between one or the other of these. Which is reasonable. Multiple requests error. What is that? You are trying to run multiple requests at the same time? Huh? What the hell kind of error should that even be for a don't actually just import this, because that's not the point. Error. Built-in type, built-in exceptions. Because I'm very definitely not trying to run multiple requests at the same time. I'm not entirely sure what gives there. There's definitely a better way to handle this kind of lazy fetching, but I like the try to load it and catch an exception if you can't approach. It's definitely like, it would probably be smarter to check if the file exists, but this checking if the file exists requires importing more stuff, and handling the exception that you couldn't find it doesn't. Also, throw back to the time that I said hour 45 minutes. We are not on pace to meet that because my I think it was like a 10-minute clip at the beginning when I was prepared to just let the thing download that wound up being completely meaningless anyway. And then this segment has gone on for an hour 44:30. So this has definitely been interesting to record. I think if nothing else it was worth doing for that, because I am having an interesting time now. But yeah, I don't even know if anyone else is going to be a little bit interested in watching this, especially because it's going to weigh in at like 2 hours, and who has time for that shit? God. I'm going to feel a little bad about not having captions. Oh. Okay. 58 megabytes. But I'm done. Okay, so when we grab the relation in build gaps, if rel id not in relations, okay, so I think that should be the minimal legitimate bruh. Okay, so there are only 3 relations in the whole list that weren't found, so that's probably a good sign. Although it's not necessarily a good sign for the data integrity of OpenStreetMap, but that's life sometimes. Okay, so we have a thing, okay, so with luck that'll do what I want it to do. Okay, yeah. So it just has no children. Okay. There's just nothing there. So let's see if that solves our issue. It solved that issue. Okay. So yeah, now that we aren't fetching every time, I should have done that way earlier. Now that we aren't fetching every single time, our process is way faster for like debugging and shit. Uh, so tags doesn't have a name. That's probably not optimal, but like, oh, so it's not even real. It is just a proposal. Hmm. Okay. Are you sure? Are you entirely confident that there are 352 miles between these two exits on I-76 in New Jersey? Are you 100% confident in that claim? I-76 in New Jersey. Oh yeah, I-76 is weird. Oh, is it that it's a state border or something? So yeah, New Jersey's being weird. So I think the way that we solve that is we have some data. Trims off weird anomalies and otherwise. Increasing is 0, decreasing is 0 for A, comma B, and zip data starting at 1. A is less than B, then this counts as increasing if key of A is less than key of B. Oh, we gotta use the thing if we want to need the thing. And logic can come later. Okay, so yeah, so we do have, so we've got 2 votes for increasing. God, that's just a mess. Okay, with luck. Okay. So we can't actually. Okay. So I-76 in New Jersey is just a weird-ass mess that nobody actually likes. So I'm sorry if you live in New Jersey and object to that statement. New Jersey's done being weird, and New Jersey's done being weird. Oh, we've got a lot of those. 10 miles, huh? You sure about that? We found a longer list than that earlier. Yeah, we had 21 miles. Fucking. Okay, whose the hell idea was all the semicolons? That just seems like a bad idea. Please. Okay. Oh, I'm not smart. Okay, so that is, yeah, that's also not, that's cheating too. Tennessee, which was that again? Okay, 74B. Okay, I-81 Tennessee northbound. I-81 Tennessee northbound. You are cursed. Oh yeah, I-35 West. That one I am familiar with. I-35 West, Texas. Southbound. And we're probably going to also need northbound too. Because, yeah, it's that junction right there. Because I think the mile markers reset. They reset on one or the other. And so you just kind of jump. That's going to be 35. Oh. Yeah, because there's no way that the actual answer is longer than like 100 miles. Shit, we could just like say that? Yeah, I don't actually believe that anymore. I-70 westbound on Kansas. Does that smell like BS? That's definitely plausible. I've been on I-70 westbound on Kansas. And I've been on I-70 eastbound on Kansas. More so, no. That's a little that's closer to the Kansas City edge. 366, 410, 70 Kansas West. 410. And then 224. Yeah, that's the that's the fucking Kansas Turnpike. All these godforsaken jumps in, like, that's not real. I'm so tired. So when we throw out 40, yeah, I'm not happy about how this has turned out, honestly. 74 North Carolina, 74 North Carolina, and we have looking for 101, 140. Bro moment. Oh, this is. Oh, this is just like completely disjoint. There are like three completely non-contiguous pieces here. Because there's down there, there's over there, and there's up there. So I think the real lesson that we've learned today is that the interstate highway system exit numbers are not actually usable for this use case, which is incredibly disappointing. But we do have some consolation prize, at least. It's not optimal, but that 21-mile stretch where I almost ran out of gas is in fact the longest gap between exits on I-25. That's still something. Well, I guess that's life sometimes. You don't always get to choose how the projects you want to do turn out. And as it stands, projects we want to do are just, yeah, because that's like 194. That's like not, yeah, that fucking disjoint mile marker is bullshit. Yeah, that's frustrating. Well, welcome to programming. Sometimes your data just sucks. See y'all if I do this again. Bye.